Hello, in this video we are going to go over the solution of the problem 1047, remove all adjacent duplicates in a string. For example, we are given a string like this one as the input and we want to remove all of the adjacent duplicates. For example, I can remove B and B first, then I have A and A, so we end up having CA. We are going to use the data structure stack to solve this problem. Okay, let's start writing the code. The first thing that we are going to do is to initiate the stack. We say stack equals an empty list. Then we are going to go over all of the characters in our string. And you could say 4 characters in original strings. And when I read the characters, I could have different conditions. The first conditions that I have is that the stack is empty, like the situation that we are initiating the solution. So if not a stack, it means that if stack is empty, so in that case I'm going to append the character to the stack and say stack dot append character. Also, if the character that we see is not similar to the top character on the stack, we are going to append that to the stack again. For example, if I have here A in my stack and then I see the character B, so I'm gonna add the character B again to the stack. So we say else if character not equal to the last element on the stack list, which is stack minus 1. In this condition, I'm just gonna add that to my stack. So stack dot append character. And the last condition is that if the character is equal to the stack minus 1, the last element of the stack list or the top element in the stack. In that situation, not only I'm not adding the character to the stack, I'm also going to remove the last elements of a stack out of the stack. So I'm gonna say stack dot pop, which removes the last element. For example, if the first B is the last element of the stack and then my character is B, so I'm not gonna add the B to the stack, I'm gonna remove this B as well. Okay. At the end, we are going to return a string, and that string is what we put together from the characters we recorded on the stack. So we say dot join a stack. Okay, now let's run the algorithm and we get the answer CA, what we expect. Okay, let's print some middle sections to see what is happening. If we do that, so first I'm reading the character A and the stack is empty, so I'm gonna add that to my stack. Then I read character B. Character B is not similar to character A, so I add that one to the stack as well. So the stack is now A and B. I go for character B. This time we are at this condition. Character B equals to the last elements on the stack, which is here B. Because that is equal, we are not adding the character. Instead, we are popped from the stack, and the stack now is only character A. Then I go and read for the next character, which is this A, character A. Again, I'm at this condition. Character A equals to the last element of a stack. So we are going to pop from the stack. Stack is empty now. We go for the character C. Character C, the stack is empty. We just add that. That is first condition. We add that to our stack. Then we have character A, and character A is not equal to C. That is the second condition, and we are going to add that to our stack. So this is our final stack, and by using the function join, we can return the string CA. Now let's talk about time complexity. Because we are visiting in this for loop all of the characters in our string, so the time complexity is order of n, where n is the length of the original string. Also, we had a stack, and that length is going at max be the n minus d, where d is the total number of all of the duplicate characters put together. So a stack doesn't have to be n, it could be less than that, because we could have some duplicates, and whenever we have duplicates, we are not going to add that to our stack, so stack length could be shorter. Okay, this is the solution to the problem 1047, and thank you so much again for watching this video.